Hey, what's up everyone? Julian here, back with another video on Python, and today we're going to be talking about password hashing, and we're going to be using a third-party library called Bcrypt to help us. So if you don't know what hashing is, then I'll give you a kind of high-level overview. So hashing is the process of taking a string and turning it into a seemingly random string of a fixed length. And that process is irreversible. It's a one-way function, so you cannot return the hash to its original string. Unlike something like encryption, where you can encrypt a message and then decrypt it to then read it again. Hashing is a complete one-way street. Once it's hashed, there's no coming back to its original form. So we use hashing in user management. So user passwords, for example, should be hashed, and the reason we do that is if you have some kind of database breach, or you lose some data, or someone hacks your system and steals a load of user data, then you've got plaintext passwords and usernames and emails all linked together all across the internet, and that's bad news for you, and it's bad news for your users especially. So hashing gives us some layer of protection. However, obviously the first point of concern is to not let your database fall into the enemy hands. However, hash passwords can be cracked, and I'll throw a link to a great video by Computer File with Mike Pound. It's a great video showing how to actually crack hashed passwords. But this video isn't really going to be about that. It's just going to show you how to actually hash and work with hashed passwords using Bcrypt in Python. So let's go ahead and get started. So I've got an editor open and a terminal. I'm going to create a virtual environment. So Python-m-venvenv, and we're going to use a third-party library called Bcrypt. Now Bcrypt is a hashing algorithm, and this is the Python implementation. So it's a really nice library. And Bcrypt is a very reliable, very robust and recommended algorithm for hashing passwords. So we're going to use it, and it provides us with some really nice, really simple to use functions that let us get things done quickly. And of course I've got a text-based version of this, and I'll throw a link in the description. So we've got our virtual environment. Let's activate it. So source nbin activate, and we'll pip install bcrypt. So pip install bcrypt, nice and simple. Need to update pip, but never mind. So let's create a new file. We'll just call it main.py, and then we'll go ahead and open that up in VS Code. So to work with Bcrypt, we need to import it. So import bcrypt, import Bcrypt, and let's go ahead and create a password and store it as a variable. So password equals 2, and just a something to note when using any of the Bcrypt functions, it must be a byte string. So we'll create a password, secret password 55. So let's actually use the Bcrypt function to hash this password. So we can do that. We'll create a new variable here called hashed, and bcrypt.hash pw, that's the name of the function, and hash password takes 2 arguments. It takes the password, and it takes something called salt. Now, I'm not a crypto expert, but from my understanding, salt is a randomly generated number or string that's used to actually hash the password. And luckily for us, Bcrypt provides a nice function to get salt as well. So we'll provide the password and bcrypt.gen salt parentheses. So that's our password and our salt passed in to the hash password function. So now let's just print hashed and see how it looks. Clear this, and Python main.py. Not sure how well you guys can see that, so I'm going to just copy it in to VS Code here. So there we go, there is our hashed password. And if we save and run this again, what I'm going to do is just go ahead and copy the second hashed password. So same password, same hashing function, but as you can see, we've got a different result. There are some similarities, which I'm not going to go into in this video, but you'll see we got this $2b, $12, and then we've got another $, followed by the actual hash itself. Now these do have some relevance, but I'm not going to cover that in this video, and that you can read more about that in your own time if you fancy it. So those are our hashes, and you'll notice that they look completely different, entirely different. So if you've never worked with hashes before, in fact, if you've got any kind of database with user emails, passwords, usernames, and you're not hashing, then just drop everything now, stop what you're doing, and go and start hashing your passwords, because the last thing you want is any kind of data breach and people who have got hold of emails and plain text passwords. Trust me guys, you do not want that to happen. So how do we actually, so you've seen how we hash a password. So what about when we want to check a plain text password versus a hashed password? So think of the scenario. So you've got a web application where you let users create an account and log in. Maybe they've got a profile or something. So they sign up, they provide a plain text password to, using a form, for example, and then you hash that password and then store it away in a database. And then they're going to come back to the site, they're going to log in, and let's say they use an email to log in plus their password. You then look up their profile using the email, and then you pull in the copy of their hash password. And now you've got a copy of the hashed versus the plain text one that they're providing. So obviously we couldn't just compare these two because they're completely different. Fortunately, again for us, Bcrypt has a nice function to compare a hash password with a plain text password. So I would recommend always use the functions that the library provides when it comes to things like comparison, especially with things like crypto, anything to do with cryptography. Trust me, these guys, they have worked on these libraries for a long time. So let's go ahead and actually compare. So what we'll do is just go ahead and use the Bcrypt compare password function. So if Bcrypt it's actually check password, check PW, and that takes two arguments. It's going to take our plain text password and it's going to take the hashed password. So password hashed, and it's going to return true or false. So we'll just do print it matches. However, if it doesn't, we will go ahead and print didn't match. So let's go ahead and run this, and there we go, we get it matches. So again, we've got our plain text password and we've got our hash, and we're comparing the two using the bcrypt.checkpw function, and if it matches, it runs it matches. If it doesn't, it will print didn't match. So think of some, maybe another way to illustrate this in the context of something like a web application. Let's say something like Flask. So you would typically receive let's say an email and a password through a form. So you do something like username equals request.form.get username and password, request.form.get password. So this is what the user has just provided through a form to our Flask app. So what we would then do is look user up in database using the username. This could alternatively be email as well. So or email. So you look them up, and if they exist, then we'll get a hold of their hashed password, which is in the database. So that will then become our hashed. And then we just run the following if statement. If it matched, then maybe we'll do something like redirect. Well, we should return redirect URL for, and let's say they've got a profile or something, so it could be user profile. However, if it didn't match, maybe we'll flash them a message saying invalid credentials and provide a warning class. So that would be a kind of scenario if you're taking user data from a form, get the username, get the password from the form, nice and simple. In fact, something I did forget to mention is because we need bytes, you would want to do something like .encode UTF-8. So using this, it's going to give us a byte string here as password. So we can then just pass password straight into the check password function, and hashed is already going to be bytes. So that's a typical scenario if you've got a web application with user management. So let me go ahead and just comment out these because we haven't got Flask. So I'll need to comment these out. So another thing we can do with Bcrypt, and it's going to be the last thing we're going to cover in this video, is called the work factor. So the work factor is kind of like how much effort or time it takes to crack or break some kind of encryption mechanism or function. And with Bcrypt, we can actually change this work factor. And the thing to bear in mind is that the higher the work factor, yes, it might, provide extra layers of security. It might make that hash harder to crack, but it's also going to take up way more resources. So, your CPU on your server is going to have to work a lot harder. Maybe the memory on your server as well is going to, it's going to use up more memory. So the work factor is something to consider. Now, by default, the work factor using the bcrypt.gensalt and not providing any arguments, I believe, is a work factor of 12. But what we can do is, in fact, what I'll do, I'm just going to comment out our original hashing function here, and we'll also go ahead, I'm just going to copy out or comment out everything now. So what I'm going to do is import time, and what we'll do is just time this. So we're going to do start equals time.time. We'll put our hashing function, and then we'll do end equals time.time as well. And then we'll just do f equals end minus start, and then we'll just go ahead and print f. So what this is going to do is just time how long it's going to take to hash. So let's go ahead and run this. So we get 0.190 milliseconds. So if we want to change the work factor, what we can do is pass the rounds argument here into the bcrypt.gensalt function. And by default it's 12, so let's step it up to 14 and see what we get. We get 0.789 seconds, and let's take that up to 15. Can already feel it's taking longer. That's 1.532, so nearly just over double. We take it up to 16. Definitely longer, so that's 3.035, and we'll just do one at 17 and let that run. So I would recommend just stick with the default now, but it may be something that you want to consider depending on your application, depending on what you are doing. So that took 6.09 seconds to actually hash this passwords with a work factor of 17. So you can see it, it ramps up pretty quickly with small incremental increases in this rounds argument here. So maybe something to consider is leaving this default. Like I said, it's set at 18, and that's actually quite snappy. It all depends on your application, depends on how long you think your user is willing to wait for a password to be hashed, depends on the power of your server, the resources that are available to you. So lots of different things to think about when it comes to Gensalt, but rule of thumb, leave it at the default and the default is 12. So leave as it is and should be absolutely fine. So I hope that made sense. I hope you learned something. And like I said, if you're not hashing passwords and you are doing some kind of user management, then I highly recommend that you drop what you're doing and start hashing these passwords. But as you can see, nice and simple, and Bcrypt makes it really nice for us. So that's everything I wanted to cover for this video. I hope you enjoyed, hope you learned something. Feel free to like the video if you enjoyed it, subscribe, plenty more videos coming soon. And as always, thank you very much for watching, and I will see you on the next one.